we'll learn about something called Git. So this is going to be day 8 of the course. Let's start with version control. So we all know, like a software as part of its development life cycle, what we call a software development life cycle. Let me grab an image for that. So as part of SDLC, a software actually goes through many changes. As a software evolves, the lines of coding keep increasing. And it keeps getting versions, newer versions. Software development life cycle. Now it has got many phases, but you can think of the major phases. Let me choose the correct diagram here. More or less, it will be something similar to this. So if we quickly go through this. Now, there are different diagrams where you will have different number of phases shown, but you can think of it like this. This is not a bad diagram. Like analysis, design, development, testing, deployment, maintenance, and then again, like if there are new changes, this is for the first iteration. Again, if the second iteration is there for the software, then again you will start from analysis, design, development. So that is why it is called a cycle. It goes on and on. Okay. So in the analysis phase, there are these are the various roles, like the chief technical officer, business analyst, project manager, product owner. They interact with they will have joint meetings. They will interact with the actual customer or representatives of the customer who would be using it. By it, I mean the software that has to be developed. Okay. Then they will gather the requirements and then they will go into a design phase once the requirements have been frozen. So once the requirements have been frozen, they will start designing it. So the UX UI designer, they are they will not do any coding in terms of actually practically, there will be no practical implementation. The user interface designers, UX stands for user experience. UI stands for user interface. They will only be creating mock-ups, as in what will the app look like? Where will there be a text box? What is the color? The look and feel, okay? There would not be any real code that they are going to implement. It is every page, how it looks like, what will be the flow after one click event, what is the next thing that is going to happen, things like that. And the system architect, they are going to actually design the actual technical solution. What kind of database, what kind of framework they are going to use, what will be the architecture, what kind of design pattern they are going to use. So this will be highly technical. Like the system architect, they are the these are like very experienced people from the development team. Actually, they are going to design how So it is something like you can think of like if a building has to be built, then it needs a blueprint. Okay, how tall the building will be, where in each floor, how many blocks, how many flats there would be, where the pillars would be, how the foundation would be, that kind of thing. So the basic building blocks for developing the software. That is what the system architect will do. And then finally, these are the developer guys. This is the development team. He will hand out the blueprint, and overall the system architect personally will not be doing any coding. Okay, he or she would be like guiding the project. They will the design, technical design, I mean, and the front end. And so developers, there are three kind. I mean, like in a 3-tier architecture application, like there is the presentation tier, whatever coding is required for the presentation tier, which the customer will be interacting with directly, like the website in the browser. All that coding is done by the front-end developers. And all the code logic, like your application tier, that and the database connections, those kind of things are done by the back-end developers. So that is where the actual development will take place. This is where they will keep changing code, keep pushing code. And then, so the rest of the phases, like, so that is why we are going to learn, because the developers will keep pushing code. That is why the version of the software will keep changing. That is why we are learning something called version control. Okay. So after that development stage completes, it is then given to the testing team, where they will test the code. And then, so in this case, and then it will be if the testing is pass, code looks okay, the expected behavior versus the observed behavior of the software looks good, then that code is ready to be deployed. When they say deploy, this deployment is happening in the production environment, the environment which the customers are directly going to use. Okay, so for that, there will be some database administrator. And then finally, once it is deployed into production, a software has to be maintained. So that is the maintenance section then. Okay, so this thing goes on and on. And in this entire, so in the analysis and design thing, you probably will not be seeing any DevOps activity. But after that, even for that, in the development stage also, you will need to do provisioning and configuration. Okay, so Dhirendra is asking if DevOps engineer comes under testing. Can you unmute yourself and ask what you actually mean by that?
Yeah, good morning. My doubt is that you are showing DevOps in testing part, and I think it comes under like an administration kind of thing. DevOps.
No. See, here DevOps will also come under development. It can also come under design. Okay. See, don't confuse it here. This is a little bit misleading actually. Or a DevOps engineer is what is a DevOps engineer supposed to do? Think of it, DevOps.
Yeah.
Okay. Primarily, the first thing they have to do is provisioning.
Exactly.
Okay. So think about it. When they are saying, when they are putting it in the testing, here the DevOps person is not doing the testing. For testing, you need a test environment, right?
Exactly.
So that provisioning that DevOps engineer is doing.
I did understand.
Yeah. Now you got it?
Yeah,
so
got it.
similarly, during deployment also, it will be in a production environment. In the development also, it has to be a development environment. Okay.
Right from the development to maintenance, DevOps engineer requirement is there where
yes.
The range of the development, the range of the DevOps engineer working is different in different parts?
Different use cases.
Yes,
What
yes.
is the, so that use case can be related to provisioning, that can be related to configuration, that can be related to deployment.
Yeah, I did
Okay.
understand.
And overall, all these things, initially it will be done manually. But once it is tried and tested that the steps are working, then it is supposed to be automated.
Yes.
Okay. So the DevOps engineer will be present everywhere.
Everywhere, right from development to maintenance.
But not mostly in this analysis phase. You can think of it not required here, because here primarily the business analyst or whoever represents the product owner. If you are saying product owner, that means you are using the agile methodology with Scrum or Kanban implementations. So that is more of a project management thing. Okay, in that case, it is called a product owner. But to keep it short, it will be somebody. So see, there is a customer who wants the software, and there is a vendor, that is the software company who is developing the software for the customer. Okay, so somebody from the vendor company needs to communicate directly with the customer in non-technical language. Customer does not know Java. Customer does not know DevOps. He or she will not be interested in. They know their business, right? They may be an online retail store. They may be a pharmaceutical company. They may be any business. They want a website, dynamic website, working real time, where they can keep making changes, because they will come up with their own sales campaigns, advertisements, changing in price, expansion of customer base, things like that. Basically, their website needs to keep changing. It should be easily accessible. So that means there will be continuous code change. If there is continuous code change, then your software development lifecycle will continuously go through these phases: analysis, design, development, testing, deployment, maintenance. Again, go back to scratch. Customer, once the first iteration is over, customer comes back. He says, in my website, there are 30 pages now. I am opening a new business line of products. So I want 10 more pages. These are the products. So again, somebody in the analysis phase, somebody again needs to, like a product owner or a project manager, a business analyst, or a chief technical officer. These are the people who are going to interact with the customer, so that by speaking with the customer in doing some manner of elicitation, those are actually business analysis tools. They can extract the information from the customer and then from using non-technical sentences, plain English. Okay, maybe maximum they might be using user modified language UML diagrams with user actor roles. Okay, because these people, I mean, like either it will be the customer directly, or it will be representative of the customer. So if if it is an employee from the customer's company, mostly they would be like real time. You would be dealing with. Like, I have worked as a business analyst and a project manager for a certain period of time. So during that time, I used to interact with representatives of the business. Okay, very rarely will you actually be interacting with the owner of the business directly, because the owner would have hired somebody to do the job. I mean, like some employee will be there. So these employees with whom you are going to deal with, they are mostly management executives. They understand their business. They are more interested in preparing sales campaign strategies, marketing, advertisement. Okay, so you have to speak with them completely non-technically. You have to like do a role play where like you are the customer and you are trying to reach out. You're trying to create new markets, new demands, demand spaces, so that you can pull in pre-orders, things like that. Okay, so that will be non-technical. That non-technical thing, then the business analyst or the product owner or the project manager has to go to in the design phase. They will simply say that customer actually wants this implemented. Maybe it is an application that they need. So like it's a mall where people come in to do shopping. So they I mean, like they want a software to keep track of all the vehicles which are coming in and parking and then leaving. Okay. So maybe you want a software like that. You want to track the vehicles. And then the mall is saying like, if we will charge the customers $5 per hour, but if the customers has actually purchased something from the mall and can show the bill where there is more than $100 of purchase, then the parking will be waived off. Fees will be waived off. So you need a software to build all of that kind of thing. And that will go to the design phase. You will gather all these requirements and then go back to the system architect, solution architect. This is just an example name that is being used in real time. So this is a role actually. The system architect that you are seeing here, this is a role. In real time, the same person might be doing multiple roles in the company. Okay, the product owner can also be working as a project manager, but the roles are different. The project manager might be working as a business analyst. Okay, it depends where you are placed and stuff like that. Okay, so I'm like, this is more of a SDLC part. But the major thing the major take that you should be taking from here is a software is always dynamic. It goes through these phases of changes, these phases, and then the change that is happening in the software needs to be versioned. That is the whole point. Okay, so now let me go back to versioning. So basically the idea here is software keeps changing. So you need to keep versioning it. Why do you need to do that? Because your software should be built in such a way that every developers, when they get a new challenge, okay, they have to do the development. They have been given the task. Solution architect has told them, okay, you do one thing, you create these kind of modules and then implement the modules individually, test your modules locally using this kind of, do these kind of function calls and library calls. Depends on the kind of software they are using. And then you integrate them and check if it is working or not. So locally, developers will, in their local systems, they will have to, in a sandbox mode, they will have to play with the code. It does not work like this, that you have been given a requirement. Okay, so prepare in the software, in a certain web page, so in the registration page, there should be a text box with the username field, password field, email, and then some captcha, and then register button. So that is a mock-up. But then to implement that, the developers will have to do a little bit of test, like some code they will write incorrect. They will try it in their local system first. So basically, they have to play around with the code. You need to give them that scope. That happens. Okay. So, for example, a software does not get built automatically. Like like the real-time example that I can think of. Let me open the browser here. So most of you would know about Firefox, right? It's a browser. Okay. Now, when did it start? Initial release date was around 2002. Now it is 2023. So the kinds of programming languages that are used in for writing Firefox, it is a browser. Okay, so it is a software. You have to, if you go to Firefox, then you can actually download and stuff, and then install and then use it as a browser. It has got its search engine and many things it has got. Now, in 2002, it was released, last week of September 2002, and now it is end of 2023. During this time, do you see, this is the version of the software. Okay, it has gone through many changes. Right now, Firefox has got nearly 3 million lines of code, and more than 850,000 times there have been code changes in Firefox. I was actually reading, I mean, like in one of my YouTube shorts, I observed it yesterday. I went through this. So think about it. Over a period of around 20 years, this software has been developed. It is still being developed. There are lines of codes have been added. 3 million, that means like 3 million is like 3, and then after that 6 zeros. That's a huge number. Okay. Now, there have been more than 850,000 times the versions have changed. Code changes have been implemented. So how do you manage all of that? That is where versioning comes into picture. So when you are going to, now let's delve into version control. Okay. Let us see version control. So basically here the idea, the problem is that a software keeps changing. Now, if a software keeps changing continuously and developers are always changing code, then how do we have a system wherein, and that too, when developers are developing software, they might be working on the same code, same piece of software code. Okay. How do they share the code without disrupting each other's work? How can you host the code so that everybody is able to view that same piece of code and they are in sync? So basically, you need to host your code centrally on the internet. Now, that is the reason why I think yesterday we have done it. Yeah, so you need to host your code centrally somewhere. Okay, that is where GitHub comes into picture. That is why so it is not my expectation, actually it is a requirement now. Before you can proceed with the rest of the course, you definitely need a GitHub account. So if you have not created your account, it is high time you create one. So this GitHub is going to be the centrally hosted repository, code repository, which will be accessible via the internet. Okay, that is one way you solve the problem. But apart from that, you also need, so this is the first part. Centrally hosted code repository. On the internet. Okay, so we have solved this part of the problem using GitHub. That is one way to share your code. Every developer will know what the other developers are up to. And if they want to see the other developers' code, they can also download it. Okay. So this GitHub is going to be our repository, but this is going to be our what we call in version control as the remote repository. There will be 2 repositories. Repo is in short, repository is always called often called repo. So I'm going to use the word repo. Repository and repo are referring to the same thing. So GitHub, so we are not going to maintain GitHub, by the way. It is just a free source, free tool. It is not open source. At one point of time, it was open source, but now it has become proprietary software. Nevertheless, it is free to use or to a limited extent. But beyond that, you will have to purchase. For our learning purpose, it is fine. We can use the free version. But otherwise, GitHub is actually owned by Microsoft now. Right. So GitHub solves our remote repository problem. But now developers, as I said, if they want to solve a technical problem, they will need to do some kind of experimentation in their own system, right? Now, if they have to do the experimentation on their own system, they will need to create a repository in their local system also. That is called a local repository. So for that, you need, so again, without Git, there is no GitHub. So just like, and GitHub is not the only remote repository. There are other companies also in the market like GitLab, Atlassian Bitbucket. There are many others, okay. Just like there are thousands and thousands of brands of cars. Similarly, there are many, many brands of cloud providers. And so this is a kind of a cloud service that the company is providing. Okay. And every company, they try to compete with each other so they can give even a better product. So if you use GitHub versus GitLab versus Bitbucket, you will see there are variations in the final output. But overall, their main objective is to be a remote repository for the code base. Now, what about our local repository? The developers will need to write their code locally, and once they are satisfied with it, then they are going to push it. Okay, so GitHub will actually connect to I have to actually draw a diagram. So I hope you have understood till this part that there needs to be a remote repo, and then there also needs to be a local code repo, local code base. Or in other words, it is called the local repository. Okay. Now, the connection between the local repo and the remote repo, the two-way exchange, this is where your actual Git software comes into picture. Okay, so Git is not equal to GitHub, or Git is not equal to GitLab. In our course, we are going to use GitHub for our remote repo. So Git and GitHub are not the same thing. Git is your actual software, which is doing the version control. GitHub is from a private company called Microsoft, who are giving you a platform where you can create your remote repository, but in the backend, they are also using the same Git technology. Okay. And just to give you an idea, like, anybody knows this guy, Linus Torvalds? This guy gave us Linux, actually. Okay. And he was the person who actually, like if you see his interviews and rest of the stuff, he's more into open source. So there is always freedom for developing new things. This is the guy who gave us Linux. We are using that actually on that one of the distributions of Linux. Amazon used that code base and prepared their own Amazon Linux too. Okay. This is the same guy who has given us the concept of Git. And then that emerged into something called GitHub. But then initially it was free. But then after that, Microsoft purchased it. Okay. So this is the same guy who gave us Linux and also Git. So that Git software, if you remember, we have already installed something in our system called Git Bash. Okay. And we are going to use that. This is while installing Git Bash, we actually installed Git, and to interact with to properly interact with the local repository, to create a local Git repository and connect with a remote Git repository, you are going to use Git Bash. So the problem that it will solve here is, first of all, your code will be centrally hosted. Every developer will have, so this local repo will mean that entire copy of code base will be available locally. Because development does not happen in silos, okay? It does not happen independently. If 5 other developers are working on the software on different modules, and you are also as a developer working on one of the module, the entire software will all the modules in the software will have to be integrated. So while you are working on your module, to see if the software functionality is happening properly or not, you will need to download and see the code of other developers also. Okay, so using Git, you can keep a local code base of the entire code in your whatever system you are working on. Okay, the laptop or the PC. So there can be a code pull and code push from the local repo and the remote repo. That is the whole purpose of version control. And using Git, you will be able to manage to do that. Okay, now there are many more things in version control, because version control is mainly related to software development. But we are in a DevOps. This is a DevOps course. This is not a development course. So I will not be dealing with the granular concepts of Git, because that is required for developers. I teach that in a developer course. Okay, so we as DevOps engineers, you will not need that. What you will need in daily life, very minimal things with Git you are supposed to do. Okay, Git pull, Git push, that's all. We are not going to get into Git merge, resolve merge conflicts, where one developer's code is conflicting with other developer's code. No, because you're not going to write development code at all. Okay, you are going to, it's not that you're not going to add files, you're going to add files, but those additions of files will be related to configuration files, not related to development code changes. Okay. Now let us see how we can do that. How we can, so basically this is part of what you are going to learn here through Git, because we are going to use it extensively. Without Git, there is the major thing that you are going to learn here is something called continuous. You might have guessed it already. Integration. You are the CI part you are doing. Okay, this is the major thing that you are going to implement, that you can do only via Git. So basically what this will help you when you are doing version control, what it is going to help you with is every code change, every file change gets tracked. Using version control, you will have a entire history of changes made. Who did what? Basically, the questions need to be answered. Who did what code change? When was the code changed? Okay, who, what, when? These questions always need to be answered, so that maybe because of, I've seen production failures happen because a junior developer missed one single semicolon in the code line. The entire application crashed. So when things crash, and that happens, the more developers are there in the system, more lines of code are getting introduced. You are making the software more unstable. Okay, you're rocking the boat here. So in an eventuality where the entire application has crashed or a major function has crashed, you need to very easily roll back to a stage where it was working, so that then you can fix the problem. So using version control, if you have this visibility, who made the change, what changes were made, when they were made, what was the last working release build, you can easily roll back. Okay, so that is what is known as versioning. You can revert your commits. Every change will be labeled with a commit message. The version control will always keep a track history of changes. So basically everything gets tracked. These are the basic concepts of version control, and which are an essential part for in a SDLC. And for implementing the version control, we are going to use the Git software. Right? Any questions till this part? If we are good with that, now let us get into basic concepts of Git concepts. Okay, so we are dealing with Git. It is one of the most popular version control tool for people who have already been in software development projects or maintenance projects. You might know there are other softwares also like Subversion, Mercurial. Okay, but then these are getting replaced with Git. Git came somewhere around, I think, 2014 or 15. And it has become very, very popular because it is easy to use. It uses the something called a snapshot technology, wherein it is, let me actually draw the diagram. So what we are dealing with here is, I mean, like picture speaks 1,000 words actually. For me, it is much easier to understand using pictures and also explain using pictures. So what you are going to use is this software. How you are going to use it, gradually I'm going to show you. So try to follow my lead here. Now, the problem that we have to solve is we need remote Git repository. Two things we are going to have: remote Git repo and local Git repo. I'm saying Git every time because Git is the version control software that we are going to use. Okay, so this one is being handled by whom? GitHub. Now, this is one of the softwares, but it is not the only software. Again, I'm repeating. There are other softwares also. In our case, it is going to be GitHub. There you go. And for the maintaining the local code repo, we are going to do it using Git bash. Who is doing where, what? I'm trying to clarify here. You already have Git bash installed in your system, or you should have. At least I have shown it in my demo, like in my virtual environment. Okay. Right. Let's see how we are going to use it then. Now, before that, let me show you a diagram wherein how it is going to work. What do I start with? I start with the Git server. So there is going to be a Git server on the internet, which is internet. Okay. It shapes. There is a Git server, obviously. Then there has to be a Git remote repo. Okay, so and then there are your so there is going to be a user interface here. And I need developers. So these are your developers who are going to keep writing the code always. Okay. And you need to wait. Let me draw one larger box here. There you go. And they are going to interact really. So it does not matter. There can be one developer. There can be 1,000 developers. Oops. Continuously, there will be code changes. Does not matter. The infrastructure using Git will be so robust that it will be able to cater to all of these changes at the same time, wherein each developer will have their local copy of the code base, but there will also be a central repository. So this Git remote repo, Git server, and the user interface that you require to manage this. Okay, all of this is being done by whom? GitHub. That is why we subscribe to this. They are providing this service. Okay. And using Git Bash and the Git client, you are actually going to, every developer here in their local systems, they will have a local copy. This is the idea here. So let us see how we can do that. But before that, we need to learn about certain things here. Let me actually show that to you. Now I'm going into the Git concept. There will be lots of, so see, it is a bidirectional arrow. That means pull and push. Whenever developer is making changes and wants that change to be part of the remote repo, that time they will do a Git push. But when the developer, so during the meantime, one developer has worked, the other developers have is working on his local system, his or her own local system. Other developers might have made changes, they might have pushed their changes. So if the developer, usually whenever developers start working at the start of day, SOD, start of day, they should do a Git pull so that before they can start their work at the beginning, they should have a updated local copy of the code. Okay, so that is when they will do a Git pull. That is why I have used a bidirectional arrow here. So now there are certain concepts in Git. Let us quickly learn that. Actually, let me write it down first. Give me a minute. Let me draw it. So you need a working directory, a staging area. The local repo. And you need a remote. Don't worry, I will explain it, but let me first draw the diagram. So here I'm actually drawing swim lanes so that we can identify where what is happening. Right. Okay. So there will be some code. Let's say we will start with one use case. Suppose you one developer has written some lines of code. Now this code resides this is the code line or on one or multiple files that the developer has written. Now, as long as the code is written locally, till that time it is called. So these are the Git stages, okay? How code evolves from one stage to the other in Git. Now here the assumption is you have got everything installed in your system, okay? I'll show you that process, but understand this first. Sorry, I forgot to add certain things. Let me actually do that. There will be a git add stage. There will be a git commit stage. And there will be a git push stage. Oops, wrong arrow. So this same code is going to actually flow. So this code right now resides. So imagine the developer is actually experimenting. He or she has been given a task to maybe create a registration page. So they have written the code for that. Now, as long as it is there in their local system, okay, Git will be aware of it, but nobody else knows that. So as long as they have written their code in their local, it is stored in their local hard disk, in their local computer, it is called working directory. It is in the working directory stage in Git. But now the developer is happy with the code and the developer wants to make this code available for other developers. So what the developer will need to do in this case is do something called git add. This is actually one of the commands. And move that code into the staging area. This is the next stage. Okay, so here Git will identify and then that these are the files and folders that needs to be changed. The existing ones are like this, and it will give you, Git will give you a clear status, like what is going to happen now. So you get a picture of what is existing and what are the new changes that are going to be undertaken. So when you do that, your files and folders for that, doing that, Git is preparing the code to be committed. So that before that, you have to add those files and folders from the working directory into the staging area. So once it is in the staging area, then you have to do something called git commit. Now you are going to commit the code. Okay. So this git commit is going to update your local repository. The files and folders which Git was not tracking till now it will, after git add, it has tracked, and your local code base will get updated with this new files and folders from this code lines that you have written. So your local repository gets updated. So see, it is the perspective, from which perspective you are seeing. Both the local repository and your working directory, they are in the same hard disk, in the same laptop that you are working on. But from the way Git is taking the snapshots, it will change when you give these commands. So when you have done git add, from you have moved your code from working directory to staging area, Git will display that these are the changes you are about to commit. Then after you do a git commit, your local repository will get updated with those changed code files. Okay. And then when you want your remote repo, in this case, the remote repo is going to be GitHub. When you want to update that, you are going to do a git push. You are pushing your code into the remote repo. And then GitHub will get updated with the latest code. Now, suppose this was for developer A. Now, developer B, she is going to start her day of work. So before she starts, what she will be doing is she will be doing a git pull. Okay, instead of a git push, she is going to do a git pull. And what will happen is multiple developers would have updated the code during these hours of work. And when the other developer is going to start their work, they are going to pull the updated code repo from GitHub into their local system. And their local repo will get updated. Okay, so this git pull is being done by somebody else who has not yet, or maybe the same person can also do a git pull, but maybe like it has been 4 or 5 hours and lots of changes have been made during this time that the original developer does not know. To be aware of the other developers' work, you need to do a git pull. Does that make sense? Any questions here before actually I implement this? I will actually show you how it needs to be done. Yes.
You have pulled a code which is already committed in the remote repository. Okay, so you will make the changes. Before committing back into the remote repo, somebody has already modified that original content. So how it will work in that scenario?
Are you talking about developers working on the same code base, same code file? Okay, yes. So as I told you, like this is not a development course. You will actually have to go through something called Git merge. Then there will be, during merge, there can be conflicts. You have to resolve Git conflicts. Git can automatically merge code. But if there are conflicts on the same, maybe in file number 4, line number 120, both the developers have written different code for line number 120. In that case, Git will not automatically merge the code. That time the developers will have to communicate with each other. They will see each other's code. There is code rebase. There are multiple other functionalities of Git, but that is from a developer's perspective. As DevOps engineers, you are not supposed to do that. You are not supposed to change the code that developers are writing. Make sense? So we are not going to delve into that part. The major thing that we are discussing here is git pull, git push. Okay, you will already you would already have that code with you. You're not going to write the code for development. Don't. So see, I'm making it very clear. DevOps, it is not that DevOps engineers do not write code. DevOps engineers also write code, but DevOps engineers write code for provisioning, for configuration. Where is it? These 3 tasks: provisioning, configuration, deployment, and maintaining CI/CD pipeline. So that is actually that automate part. Okay. So what you have just now asked, I'm sorry, there are too many names for me right now. I did not realize who was speaking. Guru Raj, is it?
Yeah.
So Guru Raj, the question that you have asked is from a developer's perspective, not a DevOps engineer's perspective. They are not going to require to do that. Okay, so we will let go that part. Let us first understand the basics of Git. And if you want to know more about it, actually you should enroll for a development course where they are using the Git software.
Okay.
Okay, so let us now see how to put this into practice. These are the basic concepts of Git: Git add, Git commit, Git push, Git pull. Okay, now you have to start from somewhere. There should be a repository, existing repository. Okay, but we don't have anything yet. So let me do one thing. Now I own multiple repositories. So one of the repositories that I have, and this code base should be enough. I'm going to give you that link. Okay, let me not use the word lab. Git practicals. Okay, so the code base that you are going to use, you can fetch it from this link. Okay. So if I go back to my page here, now the first thing that you should do is log into your GitHub account. Okay, you should have your name here, your account details, and then open a separate tab and copy and paste this link which I have given. Okay, so this is code somebody else has written, and think of it like this. So these are the files that we will require for our project, files and folders. So you don't need to bother about this, because once again, we are while learning in this course, we are only doing a role play. We are actually not developers. Okay, but you will be using GitHub to pull the code or to provision it. Okay, you will need links. So go to this link, open this link, and so see, this has been code has been written by the user Prometheus 13 Titan. It's a different user, and you are logged in as with your own user ID here. Okay, but you have opened the publicly available link provided by this user, and the name of the project is DevOps Basics, right? So once you open this, make sure you have logged in. Okay, if you don't log in, you can't. So the objective here is to copy the code base from this link. What you can do is and create your own repository, remote repository. This is someone else's repository. So to make a remote repository of this entire code, all you need to do is click on fork. So forking means you are basically doing a copy paste. You are creating a new copy of the existing code base. So I'll leave the name the same, DevOps Basics. But here, this time, your repository will start with your name, your ID. Okay. And uncheck this box because you don't want only one branch. In my case, however, there is only one branch. So you want the entire thing. Okay. So, and then just go ahead and click on create fork. Once again, I'm saying you are actually copying the code repo of somebody else. Okay, now it is going through that process of copying that entire code base from the user Prometheus 13. And now if you see, forked from, but if you check the header here, it is B71 DevOps Basics. So this is now your repository. This is your personal remote repository, Git repository. Any questions before I proceed? For your practice, you are going to use your own remote repository link. Do not use mine. Okay. This one is only, I'm giving you this link so that you can fork it from here. For your practice, basically log into your GitHub account. Number one, fork this repo. Number three, use your repo for course practicals. Okay, do not use my repo here. Otherwise, you will not be able to learn. So this forking has been done. Now, yeah, I'm actually open to questions here now. Anything? Okay, then you better do one thing. We have run out of time. Everybody has office and other tasks. So let us continue this tomorrow. where we have created our remote repo. Okay, we have done till this part only. Where is it? This remote repo is done. We need our local repo now. This part is pending. Tomorrow we will create our local repo. That basically means all these code folders and files which are present, which are being maintained in the GitHub remote repository. Somewhere in the world, some database, some server is there, which is maintained by Microsoft. It is present there. But I now want it in my local system. I want it here. Okay, so there is this my projects folder. So here I want it locally. I want to be able to use that as a developer in my local system. Tomorrow we will go through the process of learning that, how we can create a Git local repo. Meanwhile, I will expect you to complete till the portion I have done here. Otherwise, you will not be able to follow with the next things that I'm going to teach. So that's how we do Git. Let's learn the local repo cloning tomorrow. Take care, guys. Have a nice day. Bye-bye.